Okay, so today I am teaching John, this is John, KCL and current division. There are two different topics, but they go with each other, so I'm going to teach them in the same video. So essentially what we're doing here, we're going to analyze different nodes. And so the equation that we're going to need is the sum of the currents coming in, right, is equivalent to the sum of the currents going out of a particular node. And so what we're gonna analyze this node first, right here, to try to find I1. So based on our equation, the currents that are going into this node are I1 and 5 amps. So I1 plus 5, I1 plus 5 is going to be equivalent to the current going out, which is 3 and 4. Right? That means I1 is going to equal 2.
Probably what you got right. Because I didn't calculate.
So next one we're going to analyze is this one here. Trying to find I2. So the current going in is the current going in is 3. The current going out is 7. I2 and I1, right? And I1 is 2. So that means I2 is going to be, so we got 3 on this side and 9 on this side plus an I2. So I2 is negative 7. And next we're gonna analyze this node right here. And when I circle these nodes, I'm circling the ones that have something to do with the one I want to solve for. So I did this one first because we have 3 known values and an unknown, so we can easily solve for that unknown. And then once we know this one, once it's a known value, we can solve for I2 by analyzing this node with 3 knowns and 1 unknown. This one has 2 knowns and 1 unknown, right? And the fourth one I'm going to do is this one because we can identify I4 with it. So for I3, the currents going in is 2, 3, and I3. And the currents going out is nothing. So I3 is negative 5. And the fourth node, like I said, is going to be this one. Well, we can either do this one or this one. We're going to find the same answer either way. The current going into that node is 6. Current coming out is 4, or I4 and 3. That means I4 is 3. Now, the reason we have negatives here is it just says that the I2 is going in the opposite direction at 7 amps. So I2 in this case is going up, right? That way on this resistor. And so since it's negative, it's just going to be going this way. And so I'm going to change the direction of I2, and I'm going to change the direction of I3 so that they can all be positive. So that's our answer for, and this is just KCL. All right, so for the second half of the video, we're gonna do current division, and we're gonna do a different problem for it. So this circuit right here, there's 4 different resistors on it, and there's a 36 amp, something over here that's producing 36 amps along that wire. And we're gonna define I2 and I1 using current division. With this equation, this is the equation you need to know.
Yeah.
So the first one that we want to do is the I2. So in order to, I guess, find, in order to define what this is, we have to find the total resistance everywhere. That's what we have to consider. And so the concept here is that current flows where there is less resistance, and so it's going to split right here. We don't know by how much. And so what we're going to do is we're going to find the resistance of this side and compare it to the resistance of that side.
Yeah.
And so the equation we're going to use for I2 is what we're going to do first. It's going to be the conductance of the resistor that the side that we're talking about, which is all 3 of these resistors combined, over the total resistance, which is this one plus this one. Right? And these are all the conductances, which we're gonna flip at the end. But for now, just understand that equation. Oh yeah, and we're gonna multiply it by the source, which is 36. So first of all, we're gonna combine these 3 resistors. So the total resistance of these 2 is gonna be 1 over 20 plus 1 over 5, the reciprocal of that. Which is 4. All right, when you do that math, you're gonna get 4. And that's the resistance of this. If this was here, right, that would be 4 ohms right there. If those 2 were combined, so we would just add that to 6 to get the total resistance, the actual total resistance.
What's his name?
4 plus 6. Right. So this side, what I just said here, right? This entire side is equal to 10 ohms. And this entire side is equal to 8. So the concept here is that the resistance on top, right, is the one that we're specifying, which is 10, except we're in conductance. So it's going to be 1 over 10, right, because that's what conductance is. And on the bottom, we're going to do the total resistance, or the total conductance. So we're going to have 1 over 10 plus 1 over 8, right? 1 over 10 plus 1 over 8. And we're going to multiply that by the current source, which is 36. So when you do this math, you're going to end up with I2 as 16 amps. So what that's saying is that 16 amps is going this way and 20 amps is going the other way, which makes sense because this whole resistance right here is 10 and that whole resistance right there is 8. So most of it's going to go towards the 8 because there's less resistance.
Yeah.
So the other one that we're going to solve is I1. And so we know I2 is 16. 16 amps is I2. So that means that I2 is going to be the source of I1, right? Because it's going to, that 16 amps is going to split right here. We don't know, it's going to go towards the less resistance. Here, let me erase this. That was in the other problem. I don't want to confuse you guys. The I1 is going to be bigger than whatever current goes over here. So we can assume that it's going to be more than 8 because that's what half of this is. Because there's less resistance over here, because that's where current goes, wherever less resistance is. But we're going to calculate exactly how much by the same way. So this way we don't have to combine any resistors because there's a 5 resistor here and a 20 resistor there, and it's the total resistance on this path is 5 and the total resistance on that path is 20. So what we're going to do is we're going to have the conductance of that 5 resistor on top and the total conductance on the bottom multiplied by the source, which is I2 right here. And when you do that math, you're going to end up with about 12.8 amps. And so these are in fact your answers to this circuit, right? Equals 12.8 amps, which is the current division version, the current division part of this lesson.